Today we're going to cover permutations and combinations. We have multiple counting methods. Most of these are going to be what gives us our total number in our sample space of probability. So as we look through these, there are going to be different ways that we can create that sample space in the event that these items are used for a probability circumstance. So we're going to talk about permutations and combinations. A permutation, I have highlighted here, is an arrangement of items in which order is important. So think of choosing from a classroom, and if there are 12 students, I want to pick president, vice president, and secretary of the classroom. And if I pick the first person, that's the president, second person is the vice president, third person is the secretary, order would matter. For a combination, it is a selection of items in which order does not matter. So maybe I have that same classroom and I want to pick 3 people, but this time they're just going to form a committee and nobody really gets a title. No matter how I pull those same 3 people, that committee is the same group. So that would be what we refer to as a combination. The fundamental counting principle, you've used this before, is multiplying the choices from each option to obtain the total number of options. Think about a menu board. We'll see one of those here in just a minute. And then our n factorial, which we write as an n with an exclamation point, is the product of the integers from n down to 1. So for example, 4 factorial is 4 times 3 times 2 times 1. So here we go with our fundamental counting principle. A menu with 4 entrees and 6 drinks has 4 times 6, or 24 possible lunch specials. Here's our n factorial. We'll use that whenever we work with our permutation and combination formulas. So for our permutation is the number of n items, and again, here's this term arranged. Arranged r items at a time is written in this form. So we're going to have n factorial over n minus r quantity factorial. In this case, for our example, it could be that we have a group of 8 students, and the first 3 that we pick out of the hat are going to represent maybe the speaker and the scribe and, I don't know, the listener, who knows. But if order matters, this is how things are going to work out. So we'll have 8 items taken 3 at a time. And when we rewrite this, notice that we have 8 minus 3 in our parentheses. We'll have 8 factorial over 5 factorial, and a few things happen here. So if we think about the expanded version of this, 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 5 is 5 all the way down to 1. And you guys know that from multiplication and division, that if it's the same in the numerator and the denominator, that it cancels out and they become a 1. So in this case, it just ends up as 8 times 7 times 6, which is 336. So if we have a number of combinations of n items taken r at a time, maybe down here at the bottom we have a group of 9 students, and I want to select 4 of them to represent the class on just a committee. This would be a combination because order does not matter. For example, we have 9 factorial in our little formula here. The difference is that in the denominator, we're going to bring in this additional r factorial. So we'll have 9 factorial over 4 factorial times 5 factorial. And again, we just have this game of simplification. So 5, 4, 3, 2, 1 will all cancel out. And then we can take it from there and cancel out even more. So 4 times 2 gives me 8. And 3 will go into 6 2 times. So we end up with 9 times 7 times 2, which brings us to this 126. So again, these are all of our different groups of items. So in this case, if we had our class of 9, and we wanted a committee of 4, the probability that that committee would consist of, any number of 4 people would be 1 out of 126. So here's our deli. It offers a lunch special, and if you choose one from each of the following types of sandwiches, how many different lunch specials are possible? So we've got a sandwich, a side item, and a drink. We have 6 possible sandwiches and 4 types of sides and 5 types of drinks. So 6 times 4 times 5 will give us our total number, 120, of lunch specials. So our example 2, you can download 8 songs on your music player. If you can play the songs using a random shuffle option, how many different ways can the sequence of songs be played? We want to use our fundamental counting principle. One thing that we can do is, if we're using our fundamental counting principle, we have 8 spots for a song. 1, 2, 3, 4, 5, 6, 7, 8. The other thing, if we start out at the beginning, I've got 8 songs that I can use. Once one of them is used, I only have 7, 6, 5, 4, 3, 2, 1 options the rest of the way down. And if I go ahead and multiply that through, it is 40,320 different ways that these 8 songs could be arranged. The other thing that we can do is, if we see that this order matters, we could do a permutation, and we would have 8 things taken 8 at a time. So we would have 8 factorial over 8 minus 8 factorial, which would be 8 factorial over 1. 0 factorial is 1. And we would end up with that same 40,320. In how many ways can you arrange 12 books on the shelf? We could take 12 books to choose for the first one, 11 books to choose for the second one, 10, so on and so forth. 12 factorial gives us 479,001,600 different ways that we could rearrange those same 12 books. So using the permutation formula, the student council is electing a president, vice president, and treasurer. And how many different ways can the officers be chosen from the 10 members? So we've got a permutation, because order does matter. Notice it says arranged 3 at a time. If we go ahead and expand this out, this will be 10 factorial over 7 factorial, which means that everything 7 and below is going to cancel, which leaves us with 10 times 9 times 8, which is 720 different ways that we could have president, vice president, and treasurer. The other thing that you can do on your calculator, these are the buttons, I guess, to push right here. We have, in this case, if you have one of the new calculators, you actually will hit math first, and you'll arrow over to probability, and you'll choose number 2. So if you have an older calculator with a gray screen, you'll follow these steps right here. If you have a new one, you'll hit math, and you'll arrow over to probability, and then you will choose number 2, and it will give you these little boxes on your calculator. So you'll see the capital P, and then you'll have a little dotted box to the left of it and a little dotted box to the right of it. This is if you have one of the new calculators with the colorful screen. 12 swimmers compete in a race. How many possible ways can the swimmers finish first, second, and third? If they are finishing first, second, third, then order matters. So this is a permutation of 12 swimmers taken 3 at a time. So we will have 12 factorial over 12 minus 3 factorial. So this is 12 over 9. So everything 9 and under is going to cancel, leaving us with 12, 11, 10, which is 1,320 different ways these swimmers could finish first, second, and third. And then following up with our combination formula, remember this is where order does not matter. So our example number 6, suppose your school requires you to choose 4 books to read over summer vacation from a list of 12. How many different ways to choose the books are possible? In this case, it doesn't matter what order we choose them in. So here for our combination formula, we'll end up with 12 factorial over 4 factorial times 8 factorial. Everything 8 and under will cancel. So 12, 11, 10, 9. And then we've got our 4, 3, 2, 1. 4 times 3 is 12. And 2 will go into 10 5 times. So if I do 55 times 9, that gets me 495 different ways that I could choose 4 books. We can also use the graphing calculator. Again, this is with the older gray screen. And if you are in a color screen, we'll do the same math. We'll arrow over to the right to probability. And then we'll choose, I believe it's number 3. You can either arrow down or whatever, and it will give you that same thing. It'll give you the little box and then a capital C and another little box, and you'll just arrow over and plug in your numbers. A service club has 8 freshmen. 5 of the freshmen are going to be a cleanup crew for the town's annual picnic. We're not giving anybody a specific job, so this is our combination of 8 students taken 5 at a time. So we'll have 8 factorial over 5 factorial times 8 minus 5, so 3 factorial. I like to use the larger number first, so everything 5 and under will cancel. 8, 7, 6. And then we have our 3, 2, 1. And all of this at the bottom is equal to 6, so there are 56 different cleanup crews that we could create. And the last part, how do you know how to choose between a permutation and a combination? In a permutation, order matters. That's the key. So if a college student is taking 3 classes to take during the first, second, and third semesters from 5 elective classes, how many possible ways can the student choose the 3 classes? Notice that it gives us a first, second, and third semester. So this tells us that it is a permutation and that order matters. It would be different if I took history, English, and science, or if I took science, then English, then history, or if I took history, then science, then English. All 3 of those are different setups. A jury of 12 people is chosen from a pool of 35. How many different juries can be chosen? The key here is our chosen at the end. And our key in the first one is it asks for how many possible ways. That helps also determine that it's a permutation. So how many juries can be chosen? Everybody is on the same level playing field, so this will be a combination. No matter what order I choose those 12, the same 12 people, no matter the order, represents the same jury. And a yogurt shop allows you to choose 3 of the 10 possible mix-ins for a smoothie. How many different smoothies are possible? It does not matter which order you put those in your yogurt. If they're going to mix it in, it's all going to be the same anyway. So this would also be a combination. One thing to look for permutations is an order that things are finishing, first, second, third. It could be that you have, like I said, items finishing or songs in a playlist. As long as it wants to know how many different ways that you can play them, that would be considered a permutation. A combination is a lot like this jury. You're going to select things for a committee where everything's on the same playing field and nobody gets a position different than anyone else's. Those types of things would lend us to be combinations.